Did you know that Saturn's rings are so thin they're almost two-dimensional? To put it into perspective, if the rings were a 1 kilometer wide sheet of paper, they'd be about 10 microns thick. Now, these rings are no ordinary celestial feature. They're a spectacle of the cosmos. Discovered in the early 17th century by Galileo Galilei, Saturn's rings have intrigued astronomers and space enthusiasts alike for centuries. Their ethereal beauty is a stark contrast to their physical thinness, a characteristic that's been a source of fascination. With a radial spread of over 70,000 kilometers, their vastness is simply breathtaking. But don't let their delicate appearance fool you. These rings are more than just cosmic jewelry. They're a complex and dynamic system, a testament to the wonders of our universe. As we delve deeper into this video, we will unravel more mysteries about Saturn's rings, so stay tuned. How old are Saturn's rings really? That's the question that has been stumping scientists and astronomers for decades. The age of Saturn's rings is a puzzle that has yet to be fully solved, and it's one of the most intriguing mysteries in our vast solar system. There are two main theories that scientists have put forth in the attempt to solve this age-old enigma. Some researchers propose that Saturn's rings are relatively young, perhaps only around 100 million years old. This theory suggests that the rings were formed by the remnants of a celestial body, maybe a moon or a comet, that got too close to Saturn and was torn apart by its gravity. If this theory holds true, it would mean that the rings of Saturn didn't exist when dinosaurs roamed the Earth. It's a strange thought, isn't it? That these beautiful, iconic rings, which have become synonymous with the image of Saturn, might not have been there for the majority of our planet's history. On the other hand, there is a contrasting theory that suggests Saturn's rings could be as old as the solar system itself, which is about 4.5 billion years old. According to this hypothesis, the rings were formed from the icy debris left over after the formation of the solar system. These two theories present a fascinating paradox. On one hand, we have a young, dynamic Saturn, constantly changing and evolving. On the other, we have an ancient Saturn, its rings a silent testament to the birth of our solar system. So, which one is it? Are Saturn's rings youthful or ancient? The truth is, we don't know. Despite the incredible advancements in technology, the real age of Saturn's rings still eludes us. This mystery underscores the vastness and complexity of the universe we live in. It reminds us that even with our sophisticated instruments and our thirst for knowledge, there are still aspects of our universe that remain beyond our understanding. The age of Saturn's rings remains one of the biggest mysteries in our solar system. Saturn's rings are not just plain ice and rock. They house thousands of tiny moonlets. Now, you might be wondering, what exactly are moonlets? In the simplest terms, these are small natural satellites or mini-moons. These moonlets, some as small as a kilometer across, reside within Saturn's rings, playing a key role in maintaining their structure. The presence of these moonlets within Saturn's rings was first theorized in the late 20th century. But it wasn't until the early 21st century, with the help of the Cassini spacecraft, that we were able to confirm it. These moonlets, while small, have a significant impact on the rings around them. Now let's talk about the role these moonlets play. Some of them, known as shepherd moons, have a crucial job. They confine the particles of Saturn's rings within narrow bands through their gravitational influence. It's like they're the ring's shepherds, keeping their flock of icy particles in line. This effect results in the formation of gaps within the rings and the creation of sharp edges, contributing to the stunning visuals we associate with Saturn. But that's not all. These moonlets can also cause disturbances within the rings. As they travel through the ring material, their gravitational pull can create waves and wakes. These disturbances, visible as bright patches or streaks in the rings, help scientists track the moonlets' movements and study their effects on the ring structure. The presence and role of these moonlets within Saturn's rings is a fascinating aspect of Saturn's ring science. It shows us that even in the seemingly uniform expanse of the rings, there's a complex interplay of forces at work. These tiny moonlets, with their gravitational influence, shape the rings in ways that are both subtle and profound. And so, we see that Saturn's rings are far from being just a beautiful decoration around the planet. They are dynamic, ever-changing systems, influenced by countless tiny moonlets hidden within their icy expanses. The moonlets within Saturn's rings add another layer to the enigma that surrounds this celestial marvel. How did Saturn's rings form? The answer to this question is as elusive as the rings themselves. This is the formation mystery, one of the most captivating enigmas of Saturn's rings. There are several theories that attempt to decipher this cosmic conundrum. Among the most popular ones is the idea that the rings are remnants of a destroyed moon. This theory suggests that a celestial body, once in orbit around Saturn, was shattered by a catastrophic event, perhaps a collision with another body. The fragments then spread out in a disk, forming the spectacular rings we see today. However, this theory has its critics. Some argue that the sheer volume and composition of the rings make it unlikely that they originated from a single moon. After all, the rings extend over hundreds of thousands of kilometers but are incredibly thin, averaging only about 10 meters in thickness. This discrepancy fuels skepticism regarding the destroyed moon theory. An alternative proposition is that the rings were formed from a passing comet. Astronomers speculate that a comet may have strayed too close to Saturn and was torn apart by the planet's powerful gravity. The debris from the comet was then trapped in Saturn's orbit, gradually forming the rings. But this theory too has its doubters. Critics argue that a single comet would not provide enough material to form the vast expanse of the rings. Furthermore, the composition of comets, primarily ice, does not completely match that of the rings, which contain a significant amount of rock and dust. These theories, while fascinating, are still just theories. They provide potential explanations but not definitive answers. The truth remains hidden, obscured by the sheer distance and complexity of Saturn's rings. The formation mystery is a testament to the enduring enigma of Saturn's rings. It is a reminder that, despite our advanced technology and accumulated knowledge, there are still aspects of the universe that remain beyond our understanding. With every theory, the formation of Saturn's rings becomes even more intriguing. Did you know that Saturn's rings display mysterious features called spokes? These are radial, ghostly features that seem to float mysteriously above the rings. Their existence has puzzled scientists for decades, ever since they were first spotted by NASA's Voyager mission back in the 1980s. The spokes appear to be made up of fine dust particles that are somehow lifted off the rings and suspended above them. They can stretch for thousands of kilometers across the rings, yet they're only a few hundred meters thick. Some of them last for a few hours, others for a few days, and then they simply disappear. Theories abound as to how these spokes are formed. One theory suggests that they are caused by meteoroid impacts. When a meteoroid strikes the rings, it could kick up a plume of dust that then spreads out, creating a spoke. However, this theory doesn't explain why the spokes seem to appear and disappear with Saturn's seasons. Another theory suggests that the spokes are caused by Saturn's magnetic field. The idea is that the magnetic field could somehow lift the dust off the rings and hold it aloft. This theory is supported by the fact that the spokes seem to be more common when Saturn's rings are edge-on to the Sun, which is when the magnetic field is strongest. Yet another theory suggests that the spokes are caused by electrostatic charging of the dust particles within the rings. This could cause the particles to be repelled from the rings and form the spokes. However, this theory also has its problems, as it doesn't explain why the spokes seem to move in sync with Saturn's rotation. Despite all these theories, the spokes remain a mystery. We still don't know what causes them or why they appear and disappear with Saturn's seasons. But one thing is for sure, the spokes are a fascinating aspect of Saturn's rings, one that adds to their allure and mystery. The unexplained spokes are yet another mystery in the vast expanse of Saturn's rings. Ever wondered why Saturn's rings are so colorful? Saturn's rings, often seen as ethereal bands of light encircling the gas giant, present us with a dazzling array of colors. From pale golds to icy blues, the spectacle is nothing short of celestial artistry. But what gives these rings their mesmerizing hues? The color variations we observe in Saturn's rings are primarily due to their composition. Saturn's rings are made up of countless particles ranging in size from tiny dust grains to massive chunks as large as mountains. These particles are predominantly composed of water ice, but they also contain traces of rock and metal. The icy particles reflect sunlight, giving the rings a bright, glowing appearance. These particles are responsible for the lighter shades we see, such as the icy blues and frosty whites. On the other hand, the rock and metal components, which are less abundant, contribute to the darker shades of gold and brown. But here's where the color mystery deepens. Some sections of the rings are reddish in color. Now this is puzzling because neither ice nor rock nor metal naturally possess this hue. Scientists believe these reddish areas may be the result of organic compounds or iron oxide. Yes, the same stuff that gives Mars its reddish appearance, also known as rust. However, the exact cause of this color variation is still under investigation. The Cassini spacecraft, which orbited Saturn and its rings for 13 years, collected a wealth of data, but scientists are still sifting through this treasure trove of information to unravel the color mystery. So, are the colors of Saturn's rings just a result of reflected sunlight off different materials? Or is there something more complex at play, like chemical reactions or space weathering? The truth is, we don't fully know yet. The vibrant hues of Saturn's rings are a mystery as mesmerizing as the rings themselves. As our exploration of the cosmos continues, we look forward to unveiling more of Saturn's secrets, one color at a time. Saturn's F-ring is arguably the strangest ring of them all. Among all the celestial jewelry that Saturn boasts, the F-ring stands out with its peculiar characteristics. It's as if the ring has a personality of its own, always changing, always surprising. One of the most striking features of the F-ring is its braided appearance. This isn't just any ordinary braid, but a cosmic one woven with ice and dust particles. Imagine a braid that's not static, but constantly shifts and changes. That's the F-ring for you. Its dynamic nature is a spectacle that has kept astronomers on their toes. But what causes this strange behavior? The answer lies in two of Saturn's moons, Prometheus and Pandora. These aren't your typical moons. They're more like cosmic shepherds, guiding and shaping the F-ring. Prometheus, the inner moon, has an elliptical orbit that brings it into the F-ring every 17 years. When it does, it pulls material from the ring, creating channels, ripples, and snowballs up to several miles in size. On the other hand, Pandora, the outer moon, doesn't interact with the F-ring as dramatically as Prometheus. However, it plays a crucial role in confining the ring and keeping it from spreading out. It's the delicate dance between these two moons that gives the F-ring its unique, ever-changing appearance. However, this dance is not a flawless ballet. Sometimes the gravitational tugs from these moons can create mini jets of material shooting out from the ring. Other times they cause the ring to kink or twist, and occasionally they might even lead to collisions, resulting in bright clumps within the ring. The F-ring is a cosmic wonder, a dynamic and ever-changing spectacle. But it's also a mystery, a celestial riddle that we're still trying to solve. It's like a tantalizing puzzle piece in the grand jigsaw of our universe. The strangeness of Saturn's F-ring leaves us with even more questions about these celestial phenomena. Saturn doesn't just have rings, it also experiences ring rain. Dive with us into this fascinating phenomenon. Imagine it's raining, but instead of water, it's a shower of icy particles cascading from the majestic rings of Saturn into the planet's atmosphere. This isn't a scene from a science fiction novel. It's a real event happening around Saturn, aptly termed ring rain. The concept of ring rain was first proposed in the early 1980s, but it wasn't until 2018 that scientists were able to confirm its existence. Thanks to the data provided by the Cassini spacecraft, we now know that the ring rain is a continuous downpour of ice particles, dust, and plasma that originates from Saturn's rings and falls into the planet's atmosphere. But why does this happen? The answer lies in Saturn's magnetic field. It appears that the magnetic field pulls electrically charged ice particles out of the rings, causing them to rain into the planet. This ring rain is more than just a curiosity. It's a key factor in the lifespan of Saturn's rings. The ring rain is slowly but surely eroding Saturn's rings. At the current rate, some scientists estimate that the rings could disappear in less than 100 million years. This gives us an intriguing insight into the age of the rings, hinting that they might be much younger than Saturn itself. However, like many aspects of Saturn's rings, the ring rain raises as many questions as it answers. How does the ring rain impact Saturn's climate? Does it affect the planet's composition or its appearance? And is Saturn the only planet experiencing this phenomenon? Or is it common across other ringed planets? The ring rain adds an extra dimension to the mysteries of Saturn's rings. As we continue to unravel these enigmas, we're reminded of how much there is to discover in the vast, captivating expanse of our solar system. Before we conclude our journey through the enigmas of Saturn's rings, let's pause for a moment to reflect on the wonders we've explored today. We've delved into the mysteries of the ring rain, touched upon the puzzling age and formation of these celestial bands, and pondered over the presence of moonlets within them. We've even scratched our heads over the baffling spokes and colors that enhance their beauty. But, as we've seen, each answer only leads to more questions, and that's the thrilling part of space exploration. Each new discovery is a testament to our relentless human curiosity and our quest to understand the universe around us. If you've learned something new from this video, if we've piqued your curiosity or sparked a sense of wonder, then please give a like to this video. We'd love to hear your thoughts and opinions, so feel free to share them in the comments section. And if you're as fascinated by the mysteries of our solar system as we are, don't forget to subscribe and press the bell icon for more such content. We encourage you to share this video with your friends and families. After all, the mysteries of the universe are even more exciting when explored together. So let's continue this journey of cosmic curiosity, and who knows, maybe the next mystery we unravel will be even more extraordinary than the last.